Hi students, thank you for joining today's class. We are into the class number, give me a second. We are into the class number 7. We are into our class number 7. And as every day, let's write our agenda for it today. Let's write our agenda for today. What are we going to learn? Or instead of saying agenda, we can make it as notes because I'll be writing many important points about a particular topic which I call as static variables. Which I call as static variables. Today, our class name or the heading of our class is static variable. Today's class is going to be very, very interesting. I'll be going slow. I'll be doing a few programs. Let's do it hand in hand. Let's try to make this class more interesting. Okay. So, static variables. Yesterday, I told you one thing. What the moment anything comes as static, then you should think that it belongs to class. So when you say it can be a variable, it can be a variable or method. So a variable or a method that is static, when you say, then you should get one thing in your mind which says it belongs to a particular class. It belongs to a particular class. So what I want to do is I want to create one class and try to improvise that class as we move forward in our today's learning. Okay, give me a second. New. Okay, when I will actually say I'll be actually saying static variable. Let me create a new class. Let me create a new class. I'll say class. By the way, this is Java, right? So I'll say language J Java. Yes, class. I'll say class name is static variable 1. Okay, I want to make that a static variable 1, open parenthesis, closed parenthesis. Let me write the main method, public static void main. So here it is string array of arguments. Okay, so I'll open my parenthesis and close my parenthesis. This we have been seeing since our day 1. This we have been seeing since our day 1. Now, I want to do something like this. Let me just say system dot out dot println. I just want to maybe, maybe just say welcome. Okay, that's it. I want to just print welcome. By the way, you might be asking, sir, we have been doing the same thing since our class 1. What else are we doing here? We just named it as welcome. But as I told you, we'll be improvising this class. So I just want to copy this. I want to make sure that my class is running. Okay. I want to save this file, save as class name dot java. So I saved it. Let me go to Mercy 2025. Let me go to Mercy 2025 and I clicked on date modified. Give me a second. Where did it get saved? Oh, it shouldn't be in Mercy. It should be in Mercy 2025. Let's say save as it is Mercy 2025. That should be dot Java. Okay, so let me go here. I want to, so there is a static variable 1, a Java file that got generated. I want to open a command prompt, open a command prompt. I just want to increase the font. Okay, I want to compile the, okay, I want to compile the class. Okay, so let me compile this. And by the way, yes, we are able to compile it and then Java, and I want to see the output also. So here, why did this welcome come in? That is because we just have written system.out.println statement. Okay, so we have a class that is ready for our experiments. We have a class that is ready for our experiments. So I want to take one static variable, say static variable. So variable. So till now, we have seen some local variables, whatever is written inside the main method, etc., etc. Yesterday or in the previous classes, we have seen a few variables. If a variable is declared inside a method, we call it as a local variable that we have already seen in our previous classes. So what becomes a static variable? If it is not inside any method and it is related to a class, this is not inside this main method, but it is related to a class, then you write it something like this static int, maybe I'll say x. Okay, so static int x, this is a class level variable. This is a class level variable. Instead of x, maybe I'll just say count. Okay, so maybe I will just say count. Maybe it's just a preference of the variable name. That's it. So what I did, I have a particular class. I write a public static void main. This is a static method. Now I have a static variable and I'm making that as count. Okay, I'm making that as count. By the way, we are not printing anything. We are not doing anything to this class. We are not doing anything to this class, but we have a static variable. So what are we going to learn by adding this line? Let me go one by one or point by point so that we are in a position to understand more about this static variables. About the static variables. Let me go. By the way, before I actually dive into some additional details about the static, I want to give some basics about maybe you can say the computer science fundamentals. Okay, generally there are generally, I'll say types of memory. Okay, so generally there are two types of memory, by the way. There are two types of memory. So one is stack memory. One is a stack memory. One is a stack memory, and the other is a heap memory. Heap memory. Okay, one is a stack memory, and one is a heap memory. One is a heap memory. So stack memory is nothing but it is used for the execution purpose. Execution purpose. Okay. One example or what we call a stack memory in our programming or in our computing is, let's say example is RAM. Random access memory. Generally, when you buy your mobile phone and when you buy your laptop, somebody will ask, what is the configuration of your laptop? What is few will say, okay, it is 8 GB RAM, 12 GB RAM. In your mobile, what is the configuration? So you say that 8 GB RAM, 12 GB RAM, etc., etc. That is called as a stack memory, and it is for execution purpose. And what about the heap memory? Heap memory is like 500 GB hard disk. Okay, 1 TB hard disk in your mobile phone, let's say 256 GB, 128 GB. So all these things are for the hard storage purposes, right? Hard storage purposes. So we can call it as storage. I'll just say storage. And then example is the hard disk. Uh, disk. Okay, so sometimes just think about the usage of your mobile. Sometimes the mobile gets hanged when you open so many games, when you open so many other things, right? At the same time, when you try to do this multitasking. Okay, when the RAM is small, let's say 4 GB RAM or even less, when the RAM is less, then the number of applications that run at the same time cannot be more than a particular threshold, right? You cannot open more than this many number of apps at the same time. But if the RAM is more, you can do that. You can do that. So that is something related to the execution, either for the game or a photo application or a video editing application, etc. But for the memory, for example, let's say the storage is full in your mobile. Like what you do in that case, you just delete your photos, delete your videos, etc., etc. That's like just think that there is a heap memory. Okay, that storage you call as heap memory. This is specific to Java, by the way. And then for the execution purpose, you call it as the stack memory. And example of our day-to-day life is the RAM. Okay, you can think this as a analogy. You can think this as a analogy. Now, we are now aware of these two storage or these two types of memories, right? Memories, right? So I want to actually now come into the class so that I can take these things into consideration while we discuss more about this static variables. Static variables. Now, I want to make the heading as loading operations. Okay, I want to make the heading as loading operations. So what are these loading operations, by the way? What are these loading operations, by the way? By the way, let me write the first point. Let me write the first point, and then let's go one by one, and try to play around with the program that we have already written. That we have already written. So, first point is whenever we are running a particular class, whenever we are running a particular class, what happens internally? What happens internally? The class is loaded into stack memory. The class is loaded into stack memory. The class is loaded into stack memory. Oh, is it stack is nothing but the RAM, right? So it is something like it is going to the stack memory when you try to run the class. Okay, let's try to understand this in some pictorial representation. I have an application called draw.io. Draw.io. This I'm using it for the teaching purpose. If you want, you can explore or experiment about this application. You have a web version as well. But even if you do not have an access to this draw.io, that's absolutely fine because nobody's asking you to use this draw.io. But when you have this 5 years, 10 years of experience, right, people would expect you to be well versed about this UML diagrams, etc., etc. But for now, at the student level, at your experience level, you need not bother your mind saying I have to learn about this. But it's a good to have good to have thing. Okay, so let me try to understand or try to make you understand what we are trying to make. So I have a let me take this. This is nothing but, let's say you think that this is a stack memory. Okay. So I want to call it as stack memory. Okay. I want to call it as stack memory. Okay. I want to call it as stack memory, which is very good. So what my first point is saying, whenever the class is running, whenever we are running a particular class, that class is loaded into stack memory. Loaded into stack memory. So what is the command to run the Java program? To compile it is Java C class name.java, and to run the Java program, it is Java class name, right? It is Java class name. Right here, we have say Java class name. Whenever you run this command, what happens is the class gets loaded into the stack memory, which is very good, which is very good. Let's go to the draw.io. I want to take my class and to take my class, let me take this. Okay. What is my class name? What is my class name? It is static variable one. Let me copy this and I want to call this one as my class. Okay. So this is my class. Okay. The class got loaded into stack memory, which is absolutely fine. This is what I have learned as part of my first point. Okay. As part of my first point, which is very good. So then what next? What next? This got loaded into stack memory. Then what? Then what? Let me write the second point for you. Let me write the second point for you. Let me write the second point for you. What is it saying? When a particular class is loading into stack memory, when a particular class is loading into stack memory, all static variables, all static variables will be loaded, into static memory. Okay. all static variables are loaded into stack memory. All static variables are loaded into stack memory. Oh, which is very good. Which is very good. Let's go to our program. So here we have one static variable, right? We have one static variable, right? So we have a static variable called count. We have a static variable called count. So this one would be loaded into the stack memory as per our point. What it says, it would be loaded into the stack memory. It would be loaded into the stack memory. So let's see. Let's see. Let's see. What I'm saying is, what I'm saying is, I'm saying, I'm saying, let me come here. So it says count. This is my static variable. This is my static variable. This will be loaded into the stack memory. This will be loaded into the stack memory, which is very good. Which is very good. It is loaded into the stack memory. It is loaded into the stack memory, which is absolutely fine. Okay, which is absolutely fine. So now, let me write one method also. Let me write one method also. No, let me not write. We have a main method also, right? We have a main method also, right? That is also static. You'd be asking a question, sir, I have a static variable. You said that it would be loaded into stack memory. What about the main method, sir? What about the main method, sir? It is method. What about the static method, sir? Again, the next point says, the next point says, the next point says that, the next point says that the static method will be the third one. This is the third point. When a particular class is loading into stack memory, all static methods will be loaded into stack memory. Will be loaded into stack memory. So let's go to our diagram. And I'd like to say that along with this, copy, I'm just pasting it over here. Okay. Along with the count, there is main method. Main method. Okay. So we have a main method also, and then main method also is loaded into this stack memory, which is again a very good thing. Okay, we have learned about the three points. The 3 points. Slowly we are trying to make a particular picture. Okay, now let's go to our next point. Let's go to our next point. What is our next point, by the way? What is our next point, by the way? When whenever whenever static variables variables whenever static variables are loading into stack memory, what happens? What happens? What happens? All are loaded with default values. Okay. All the static variables are loaded with default values. All the static variables are loaded with default values. Is it? Let's see. Now, what I want to do is, here we are saying we are loading it with default value, right? What I want to do is I want to print this one. System dot out dot print ln. So I want to say, what is that? Count equal to plus count. I want to print my count. I saved this, by the way. Let me compile this. Yes, I'm able to compile this. Now let me run this. And when I run, yes, you see the count is 0. You see the count is 0. Count is 0. By the way, the default value of an integer is 0. The default value of an integer is 0. By the way, we'll be seeing all the default values as well. We have seen the different data types in our previous class. We will be seeing about all the default values maybe in the later part of our today's session. Okay. So I want to do some coding, some modification, or maybe I'd like to actually say what are the default values. By the way, if you remember, what are the different data types that we have learned previously? You remember what are the different types of different data types that we have learned as part of our previous classes? Let me write them down one by one. So it is A, byte, B, short, C, int, long, float, double, double. So okay, float, double, and then boolean, character. Okay, so these are the different data types that we have already learned. Okay, that we have already learned. So let's see what are the different data types that what are the default values? 0 is the default value for a byte, and 0 is the default value for a short, and then 0 is the default value for an int. Said for an int also it is 0. Okay, and then for long also it is 0. For float it is a decimal point number, so that is why it is 0.0. And for a double it is again 0.0. What about boolean? Let me make it. Okay, so what about boolean has the default value of false, and then character has the default value which is a empty character. So what? There is nothing inside a single quote. This is a empty character. This is a empty character. So all these are the default values of the data types or the primitive data types that we have learned about the previous sections. Now we have seen one class example where we have a single what you call static variable, and we are trying to print the static variable. So what I want to do is I would like to maybe create a new class. I'll just say I'd like to create a new class, and I would like to say it as class static variable 2. Okay, static variable 2. I'd like to make it as language and then Java. Okay, so I'd like to make it as language and Java. Language and Java. Okay, so let me give me a second. Let me open the parenthesis and then close the parenthesis. So here, what I want to do is I'd like to say public static void main string array of args, string array of arguments, and then open parenthesis and then close parenthesis. So here what I want to do is static variable. I'd like to say count. Okay, so instead I'd like to take the I would like to take the I'd like to take all the default or all the different types of what do you call primitive data types. I'd like to say primitive data types. Okay, static first one is byte. I'd like to say B byte. And how many are there? Total there are 8. So let me write them. I'd like to copy and paste all of this. 1, 2, 3, 4. Right. I have to say 1, 2, 3, 4. Okay. Byte, short, int, long, float, double, boolean, and then character, right? So I want to name different names as well. So it is short as S. Okay. So int, I want to make it as I. For long, I want to give the name as L. Okay. For float, I want to name it as F. For double, I want to name it as D. For boolean, since B is already there for byte, I'll just say boolean is bool and character is, let's say, C. Okay, all these are the different primitive data types. I want to check, since all these are static data types or static variables, I would like to check if these are getting loaded with the default values or not. For that, what should I do? I should say system dot out dot println. So maybe I'd like to say B equal to plus B. Okay, so B equal to plus B. I want to make it as, let me copy all these, copy, and then I'd like to copy all these. Yes, so S equal to, then S. So similarly, I equal to, and then I, and then similarly, L equal to, and then L. Okay, and then what is the next one? F, which is float. Float equal to, and then float, double equal to, and then double, and then boolean equal to. So I'll just say bool, and then last is C equal to. So what is the experiment that I'm trying to do over here is, as per our rule, whenever we are trying to run a particular class, the class is loaded into stack memory, and all the static variables will be loaded into stack memory. Whenever the static variables are loading into static memory, all are loaded with default values. So we have 8 different primitive data types and everything has a default value. Let's try to understand if these are loaded with the default values or not. By the way, I want to save this program. Copy. I'd like to save as class name.java. Okay. So let me just clear the screen. I'll say Java C class name dot Java, and then Java class name. So here you can see 0, 0, 0, 0, 0.0, 0.0 false, and then an empty character. And then an empty character. The same thing that we have written over here. 0, 0, 0, 0, 0.0, 0.0 false, and an empty character. With this, what I wanted to prove is, there are various primitive data types which are static. We have written static, so that is why these primitive data types are static in our context, and all these are loaded with the default values. We are very happy because we are able to prove whatever we thought that was a theory. Now, what shall we do is, let's go to the next point. What is the next point, by the way? Let me write it down. I'd like to write it down. So let me write it down, saying this is also an interesting point. I'd like to say, once static variables are loaded, what happens when static variables are loaded with the default values? Once static variables are loaded with default values, then reinitialization happens from top to bottom. Reinitialization happens from top to bottom. Reinitialization happens from top to bottom. Oh, is it? Let's go to a new. program. I'd like to create a new program. I'd like to say static variable 3 file. I'd like to say new. Maybe I'll copy whatever is there in my static variable 1. So I'd like to copy over here and let me try to make this as static variable 3. Okay. And then I'd like to say language is Java. Okay. I want to save this. Save. So class name dot Java. Yes, I'm able to save this. Now here, what happens is this is the first program, the static variable 1, that program only. I've just modified a little bit. So here, what is happening once all the loading happens? It says that let's say I'm giving the value as 100. The value as 100. What I just wanted to say is once variables are loaded with default values, reinitialization happens from top to bottom. We have this class over here. Once everything is loaded until the default values, then again from top to bottom, from line number 3 to again, it will come to the line number 9. And what it will see is if there is any static variable, reinitialize that. If any reinitialization is there, reinitialize that. So I want to do, or I want to prove something. Okay, so here I want to make it as count. Okay, and then maybe I'll take one more static variables. Static int count. So I'll just say a new static variable called count new. Okay, so I want to make this as let's say 100. I want to make it as 100. I want to print count and I want to print count new. Okay, I want to print count and I want to print count new. Let's see. Copy. Let's say count new and then count new. This is fine. Let me save this. So I'd like to copy here and try to see what happens. I'll say Java C class name dot Java, right? So again, Java class name. When I do this, what happens is the count is coming as 0, the count new is coming as 100, right? Let's try to go to this diagram and try to see what happens internally. So now initially what will happen is we have our class and we have two static variables, right? Let me remove everything. Okay, so here we have static variable 3. Okay, this is static variable 3. This class is getting loaded first. Now. So we have count and count new, right? So let's say we have a count new. So I want to I'd like to say count. We have this variable, right? And then we have one more. Which is count new. And then we have one more. We have the main method also, right? That also gets loaded. We have a main method and that also gets loaded. So we have count new and the main method. So all these three things will get loaded. But once it is loaded till line number 3, all are loaded with default values. Since both count and count new are having int as the data type, this one will have 0 as the a default value, and then again it will have 0 as the default value. Okay, so this is the default value 0 and this is the default value 0. That's fine. But what is my rule saying? Once it is loaded with the default values, again, the last rule that I have written saying, once the static variables are loaded with default values, the reinitialization happens from top to bottom. What is the stop? This is count. Is there any reinitialization happening? There is nobody reinitializing it. So it doesn't matter. There's nothing to be done over here. Now on line number 5, we are reinitializing this value to 100, right? To 100. So what will happen is this value of 0 will be reinitialized, will be reinitialized, will be reinitialized. Give me a second. This. Okay, this will become 100. This will become second, 100. This will become 100. This will become 100. Why is it becoming 100? That is because the reinitialization that is happening. Maybe I'd like to make this one as some. Yeah, I'd like to strike this. Okay. The 0 is getting struck off and then it is becoming 100. Why is it becoming 100? Because on line number 5, I'm making this as the reinitialization, This rule is also very important and very easy to understand. Very easy to understand. Very easy to understand. Okay. So by the way, maybe it's just a mismatch in the sequence. What I want to do is methods, all the static methods are loaded into stack memory. This will happen once all the variables part is done. Okay. It is just a sequence that is 4. This is 3. This is 4. And this is 5. By the way, there's just a small correction. So there's just a small correction. So main method will be loaded as the next step. First, all the variables part is done. All the variables part is done. Okay. The reinitialization happens. Then the what do you call the static methods would be coming into picture. So maybe I'd like to correct this one. So here we have a count that gets loaded with default value. We have a count that gets default value from top to bottom. Again, what happens is the what do you call static variables will be reinitialized. And once that is also done, then there comes the main method. The main method that will be loaded because that is a static method. Because that is a sorry. Because that is a static method. Give me a second. Because that is a static method and that gets loaded. Yeah, that gets loaded once the static variables part is completely done. Okay, so we are fine till now. We are fine till now. Give me a second. Okay. I don't want to save this anymore. Yeah, so we are fine. We are fine till now. Now, here comes one more important point. One more important point. What is that point? This we have been seeing since quite some time, or in the previous classes also. What happens is JVM or JVM. What will JVM do? JVM will start executing main method. JVM will start executing the main method. That's it. We have seen one diagram, right, where the programmer is writing whenever I say Java and then the class name. So whenever I execute this command, I have the class, I compiled it, I have a .class file. Now can you please run it? So what will happen internally is when I give this particular command, first the class is loaded into stack memory. Then all the static variables will be loaded into stack memory. So all the static variables will be given the default values. Once the static variables are with default values, a reinitialization happens from top to bottom. Then all the static methods also will be loaded into stack memory. JVM will figure out where is the main method and it will start the execution from that particular method, So I would like to actually take one more example, and try to make things very clear for you. I'd like to open a new, or I'd like to create a new class. So I'll say Control N, class class name, I'd like to say static variable 4. So here I want to take the language as Java, open parenthesis, close parenthesis. So here I'd like to say public static void main, and then string array of args. Okay, I'd like to say string array of args, string array of arguments. So I have the string array of arguments. So here I would like to take one static variable, static variable, static variable. I'd like to take one static variable. So what it is, I'll say static int, let's say count equal to maybe, or I'd like to not initialize this one. This is just a static variable. Okay, I'd like to have one more method. Which is static method. What is that method? I'd like to say public static process, and it doesn't return anything. So I'll say void process. Okay, I'd like to say process. So when I open the parenthesis and then close the parenthesis. Okay, so in this process method, what I want to do is I want to process the count. Maybe I'll say count equal to 200. Okay, count equal to 200. But for my understanding, what I'd like to do is I'd like to initialize my count equal to 100 also. Okay, I want to experiment with this program, right? Initially, my static variable called count is 100, and in the process method, I want to make it as 200. Okay, so I want to call. Okay, this is how it is. Now, what I want to do is I'd like to print my count method. So I'd like to say system out dot print println. So I would like to print, maybe first I'd like to print a few dashes. Okay, I'd like to print a few dashes. So here, what I want to do is I want to print, sorry, I'd like to print, what I would like to print is count equal to plus. Okay, I want to print count equal to plus count. I want to see what the count is. Okay, and then what I want to do is I'd like to give some additional dashes. Okay, I would like to give some additional dashes. So here I want to call the process method. Okay, I'd like to call the process method. And then I want to print the count once more. I'd like to print the count once more. So here I want to say process method starts. Okay, the process method starts, and the moment process method ends, I'd like to say process method ends. Okay, process method ends, and that's it. I do not have anything else right now. I would like to run this program. We have done some part of experimentation. So let's see. It is Java C. Okay, program name or class name .java. Let me quickly go to the console. I'd like to clear the screen. Java class name .java. I'm able to compile it properly. Oh, sorry. I'd like to say Java C class name .java. So when I do this, I'll say Java class name. So here you can see the count is initially 100. Let me copy this. I have to paste it over here. And I'd like to paste it over here. So what happens is count is initially 100. First, this is getting printed. The count is getting printed because this is 100, right? And then I'm just printing one more dashed lines. The control came to the process method. We have initialized that value to, let's say, 200, and then we are done with the process method. we came back and we want to print the count once more. So we are getting the 200 as the output. I'd like to go step by step what happens. I'd like to go step by step what happens. Okay. So here we have static variable 4. We have static variable 4. We have static variable 4. Okay. So we have this class. Let's say I'd like to remove all these things. Remove, remove, remove this. Okay. Remove this. Now, what will happen is first our program says we have the static variable called count. Okay, we have only one static variable called count. So let me say count. Okay, so that is getting loaded. First, the static variable 4 will get loaded as per our rule. Whenever we are running a particular class, the class gets loaded into stack memory. So this is stack memory. Static variable 4 gets loaded into stack memory. So, and then when a particular class is loading, then all the static variables will be loaded. What is the static variable? We have only one static variable, which is count. Yes, that got loaded. Now, what is my next rule saying? Or my next step is saying that all the static variables are loaded with default values. What is the default value of int? It is 0. It is 0. So I'd like to say count got loaded. Count got loaded with a value of 0, which is again fine, Once the static variables are loaded with default values, reinitialization happens from top to bottom. So what is the reinitialization? This is at the top, right? Okay, we have a count variable. So we are initializing that to 100. So let me go here. We are saying the reinitialization happens from top to bottom. I'm making it as 100. That is fine. Then what is the next step? A particular class is loaded. Then all the static methods also will be loaded into stack memory. So let me go here. What are the static methods? We have two static methods, right? We have two static methods. One is main method, and then the other is process method. Okay. So we have main method and we have process method. Then once the methods are also loaded, static methods are also loaded, JVM will start executing from main method. JVM is calling this main method. So the control came to the main method. So from this main method, what I am doing is I'm calling the process method. And inside process method, the count is getting changed to 200. So inside process method, the count is getting changed to 200. So let me go here. And that becomes 200. Okay, that becomes 200. So that is why when I see the output, initially it was 100. Before the process method was called, and then that became 200. It is so very easy to understand the flow. Previously, it's very hard because we don't know what was happening internally. But now it is very, very easy, and you can experiment with this kind of programs so that you would be well versed of what we are trying to learn. With this point, I'd like to add a few additional notes about the static variables, or I can say static members. So I'll just say static members. So what are static members? Static members are nothing but variables. Static members are nothing but variables and methods. Okay, variables, static members are nothing but the static variables or static methods. They have different names, by the way. People call them with different names. Generally, when a few people ask about static members, not everyone call them as static members. Okay, there are a few people, or there are other names also to it. So one such name is class members. So as I told you, if you see something related to static, it belongs to a class. Okay, that is what I've been telling you. So that is why the static members are also called as class members. That is a different name to the static members. Or there is one more, which is global, members. So one such example is class Blackboard. Class Blackboard. So when I say static member, it is one per class. It is one per class. So let's say there are so many students. There are 20 students, 25 students who are uh, who have attended this class, who are attending this class. Every student has a notebook. Every student has a pen. Okay, that is specific to that particular student. But what about the class Blackboard or the screen? Or now I have shared one screen, right? What about that? That is a single one. Every student gets affected when there is a change to it. Every student gets affected when there is a change to it. So for example, I've written something on the Blackboard. Okay, all the students will see because there is only a single Blackboard. Okay, if I rub with a duster or if I destroy whatever has been written on the Blackboard, then all the student will get affected. But let's say there is a student who has written in his notebook, then that belongs to him only. So what I wanted to tell is static member is nothing but a global member that is like a class Blackboard. And if there is any change to that member, be it method or a variable, the whole class, gets affected. It's not specific to a method. Okay, so I just wanted to highlight that one also. And there is one more name. There is one more name. So there is one more name, which is universal members. It is just just a different name. It is just a different name. So this is one. These are different names on which the static what you call members are called by different people. Okay, so here there is other important point that I wanted to mention. What is that? What is that? What is that? For a derived type like string, okay, or I can say non-primitive. For a non-primitive type like a string, the default value is null. The default value is null. The default value is null. Okay, so what I want to do is I want to experiment the same. This is the last program. Maybe for this class, I'd like to say file, save as class name. Oh, sorry. I'd like to take a new I'd like to take a new file. So I'll say class. Like public. Then I have to take on primitive variable. So maybe I'll say string name equal to, or maybe I'd like to say string name. Okay, and to print, I'm to print what is the default value. I'll say system out dot println. So I'd like to say name equal to plus name. Okay, so this is the default value. Since I'm experimenting, right, I'd like to have one more. I'd like to have string, let's say employee name. I'd like to say employee name, and I want to print employee name also. I want to say employee name and I want to print the employee name also, but I want to initialize the employee name to a particular value, which I'd like to say is Mercy. Okay, which I'd like to say as Mercy. So quickly what I'll do is I'll save this, I'll save this, I'll save this, and then I'd like to experiment this by running this class. Java C class name, sorry, Java C class name dot Java. Yes. Okay. Non-static variable cannot be referenced from static context. Okay. By the way, these are non-static variables, right? So I want to make them as static. Yes. I want to make them as static. I'm saving this once more and I want to compile this. Yes, I am able to compile it properly. Now I'd like to say, or maybe I'll just say, I'd like to compile this properly and then, so let me run this also. So the initial value is null that I have already shown you, and then it is reinitialized to a value called mercy, the same thing that I'm able to print over here. So I've given you all the rules and the sequence in which the class loading happens. There are a few other important bits and pieces that are in relation with all these, which we'll be covering in our tomorrow's class, hoping the class is adding value to you and you're able to understand the things properly. Just give me a second. So with this,